The functions f and g are defined by f sends x to e to the x plus 2, and g maps x to log n x for x bigger than 0, and f was for all x on the real number line. State the range of f. Find f composite g of x, giving your answer in its simplest form. Find the exact value of x for which f 2x plus 3 equals 6. Find f minus 1, the inverse function of f, stating its domain. On the same axes, sketch the curves of the equation y equals f of x and y equals f minus 1x, giving the coordinates of all the points where the curves cross the axes. So let's have a look at the question then. Here's all the parts here. Okay, so state the range of f then, first of all. So let's do that. So the range of f is, okay, well, e to the x plus 2. Quick sketch here. E to the x is going to shoot up like that. So if we add 2 to it, it's basically going to be above here. So the range will be from 2 upwards, won't it? But not including 2. So x comes down 2 but doesn't touch 2 and goes up to infinity. So that's the inequality then that satisfies the range of x. So we can just put that a bit more correctly. Is x such that, I'll put it in abbreviation, such that x lies between 2 and infinity, but doesn't touch 2. So that's the range of f then. Find the f composite g and simplify. So f of g of x then, fg of x is equal to f of g of x, which is equal to f of g of x, which is log n x, which is equal to, and x, f sends something to e to the something plus 2. E to the something then, plus 2, and that's equal to, e to the log is just x, so it's x plus 2. So there's our composite function. C. Find x when f of 2x plus 3 equals 6. So f of 2x plus 3 then is equal to, so we know it's e to the x plus 2. So e to the, sorry, what was it again? X plus 2? Yeah, e to the x. Our something is this, so it's 2x plus 3 plus 2 is equal to 6. So move the 2 over. E to the 2x plus 3 is equal to 6 minus 2 is 4. Then move the e down and write the equivalent logarithmic version of this. So the e swings down to be the base, and the 2x plus 3 that's an index can just drop down to ground level. And it's the natural log of 4 then, isn't it? And so that tells us that 2x is equal to ln 4 minus 3, so we just moved the 3 over, and lastly x is equal to then, now we move the 2 from times on one side to divide on the other side. So there's our x value for part C. Okay, so that's that part done then, and we've written it like that. We could actually tidy that up just slightly. X is equal to, split the fraction up then, ln 4, so that'll be a half of that, minus 3 over 2. That's part C. Part D then, find f minus 1 stating domain. Well, the domain of this will be the range of f, and we've got the range of f in part A, is this. So let's get f minus 1 then. Here's f of x. D. So f of x is equal to y is equal to e to the x plus 2. So let's move the 2 over and write it from right to left. E to the x will equal y minus 2. So that tells us what x is. Move the e down to be the base. ln of this thing here, y minus 2. And so that tells us then that f minus 1 of x, so this is our y, is equal to, swap the symbols, ln x minus 2. And this is true for x is bigger than 2. And that's the domain, because it was the range from before, wasn't it? So, we've done that. Sketch y equals f of x and y equals f minus 1x. And mark axis crossing points. This is the last part then. So, we need to... I'm just going to do it casually, actually. Well, I'll choose some straight lines. Just use the ruler to draw a couple of straight lines. That's not very cleverly drawn, is it? Pen. Okay, there's the x, there's the y. Just going to move the x-axis slightly down a bit. Right, okay, so f of x is e to the x plus 2. And remember it was on the entire number line. So we drew this at the beginning of the question. I'm going to just draw an asymptote here at 2. Because we noted that it's just e to the x shifted up by 2, so it's going to come down and go through 3 and then tend toward 2 here. So that's the curve, easier to draw for me with a digital pen like so, with the dashed lines. So there's our function here, and this axis crossing point is 3. Okay, good. Now we want to draw the inverse function, which is log of x minus 2 for x bigger than 2. So here's the value 2. So let's draw that in as a vertical asymptote here. And I'm now going to draw the log function. So we just draw the log function shifted over 2 units, isn't it? So it'll be coming up here and turning like so, won't it? So I'm going to draw it like so. When does it cross the axis? When x is 3. So it's going to come around like so and turn like so, isn't it? Down to here. Tend towards this. Probably a little bit more quickly, just like that one did. Okay, good. That's the sketch then of this function.